I introduce myself as a recovering architect these days because a lot of my time is spent going back and forth between architecture and engineering and construction firms and talking to people about what kind of concerns that they have and what their technological problems are, what the opportunities are, and going back and talking with product groups back at Autodesk where we start developing different softwares and approaches and workflows and documentation about issues that we see coming up in architecture, engineering, and construction. We're also starting to get more involved with my particular group in manufacturing and fabrication workflows, and occasionally even into things like media and entertainment. Autodesk, for those of you who don't know, really sort of covers that whole span of work from everything from the software that's used to make motion pictures to video games to manufacturing and fabrication tool sets, and probably with the group that is here today, architecture and engineering software. How many people here, by the way, are architects? Okay, so it looks like most of the room is architecture. Anybody in engineering? Bill Allen.
Oh, Zach.
Hey. Engineering? A couple people in engineering? Great.
Yeah.
I'm going to be talking mostly about Dynamo today, which is a visual programming environment that is available to run in multiple different software, although its primary users are coming from the Revit world. How many people here are Dynamo users of some fashion? Looks like about half the room of, what do we got, like 30 people here maybe? How many people have not heard about Dynamo before now? One, couple. And how many people here administer or manage other people's technology? So it's about half the group. Okay, and how many people here are actually usual ChiNamo Dynamo user group members? About half the group. So it looks like we got about half the group coming from outside and then maybe half the group coming from this office here. Okay, so just to sort of get a sense of it. So again, what I'm going to talk about here is my assumption coming in was that people sort of were relatively familiar with Dynamo. I can backtrack and show a little bit of other things about it. I'm going to start off just by talking about some of the most recent things that are coming out with Dynamo. So sorry if you're not familiar with the software to begin with. Might be a little bit of catch up. So I'm going to cover some of the things that are available now that you can just go and use. And then I'm going to get into some of the futures of where we're going with some of the software. So it also helps just sort of run through this quick. We are, whoever is on this screen, it looks like we've got. This is just our standard safe harbor thing. I'm going to show some technology that we haven't released yet. I'm going to talk about some of the stuff that is still sort of speculative that we're working on. Don't buy anything based on what I've talked about because we're going to change it, and it won't look quite like what I'm showing right now, but it's going to give you an idea of the direction that we're going in. Again, I'm going to start off with some stuff that's going to be more specific to people who are Dynamo users and are sort of actively involved in the software work. A few things just to sort of say, some recent things that have come out and some recent developments. When I say recent, I mean in the last 3 or 4 months, some of the things just so that people know about it. We did an update to Dynamo recently that came out in Revit 2019.1. It had a number of bug fixes. There were a few things that came out with the latest release of Dynamo that we wanted to just use some fixes for. The way that search works, there was a few things about library stuff. And just some file compatibility. For those of you who are using Dynamo 2 point something, please make sure that you're updated to the most recent version because we have some nice critical bug fixes in that. We also have done some recent updates to the Dynamo Primer, which is the main way that we get education out about how people can use the software and how people can interact with it. We did a big update for the 2.0 release where there was a lot of things that changed in our interface. We did some documentation about some of the new features, that sort of thing. So if you haven't visited the primer in a while, you can come back and check it out. We've got some new things on that. We've also added developer resources. For those who aren't aware, the way that Dynamo works is that it's an open source project, and people can expand it and use it in ways that were not necessarily intended or expected by the people who made it. And we've added more documentation around those things that allow people to sort of expand it and use it in different ways. There's also some new work that we've done around new abilities to expand what Dynamo can do. So there's been a tradition in Dynamo for a long time of how people can create functionality and expand functionality, and we've added new tools around how that can happen, known as extensions. Extensions are a way that basically you can take the interface of what Dynamo has available out of the box and basically manipulate the entire interface. How many people here have downloaded a package from the package manager? Looks like most of the room that has done some Dynamo work has done this. Package manager is a tool within Dynamo where we give a collection of tools that are available sort of out of the box. When you're running it in Revit, you can open up Dynamo for Revit, and you have all these logic tools so that you can describe things like addition, subtraction, conditional statements, filtration, so you can pull stuff out of Revit, you can make some manipulations on it, you can dump stuff back into it. We don't expose all the possible things that you could do with Revit or all the possible things that you could do with computation, but we've given a portal out to the rest of the world where other people can contribute expansions to that. The way that that's worked so far has been that you can go to the package manager and you can get nodes. You can get individual functions that you can drop into Dynamo to do additional work. And what we've added to this is the ability to actually manipulate the environment of what Dynamo allows you to do. So rather than saying, well, Dynamo doesn't have a node for placing MEP hangers, or Dynamo doesn't have a node for doing a specific kind of Revit function or interaction with Excel, for instance. So traditionally, that's been the way that we have sort of had the easiest facility for people to expand what Dynamo can do. What we started allowing you to do with package managers to, again, change that entire environment. One of the ways that you can see what that looks like is, this is one person, this is John Pearson of known also as 60-second Revit, who's made an extension which allows you to organize your nodes and basically create alignments with them. So, whereas in the past, what you could do is you could go to the package manager and you could get new functions to do specific things. Now you can go to the package manager and you can get things that basically can change your whole environment. So that you have new tool sets to aid in the production of these workflows. There's a lot of other things that you can do with this kind of functionality, and it's both powerful and can be potentially scary, frankly. The package manager allows you to download code that comes from the interwebs, and you should proceed with caution, as with anything you download from the internet. One of the things that the extensions allow you to do is you can have stuff running in the background of your Dynamo session that can allow you to organize your graph. One of the things that we've seen the managers doing, and this is why I was asking how many people here manage other people's software, we've started to see people build out extensions so that they can instrument their own systems. That is to say, they want to gather analytics on how people are using Dynamo or how people are using Revit. What this allows you to do is that when you fire up Dynamo, you can actually just monitor environmental aspects of the application. You can see how many times has this particular graph been used? What kind of projects are people using it for? You can ask really all sorts of questions on it. And one of the things that we have seen are people trying to sort of track usefulness of particular scripts so that they know where they're getting return on their investment for different scripts that they're making. Also, I mean, again, this is just sort of starting now. We're starting to see a few different people that are making these tools. and starting to distribute them. I can actually show you one example right now of what that functionality looks like. This guy right here, Andreas Diekmann, long-time Dynamo user and contributor to the community. Anybody here familiar with the Clockwork package? A few people. It was one of the first packages that was out there. It's been very well received. Andreas is now getting into the business of making extensions. And I can just show you a little bit about what this looks like. So I've got Dynamo up. I've got, here, let me just get rid of this. And this always looks weird to me and to many other people. Like, if you open up Revit and then, like, get rid of your palettes, everybody kind of goes, well, that's weird. And just because I've only got 2 screens here, so I've got my Dynamo and I've got my Revit up here, and I'm going to open up the structural framing sample, which is just one of the standard sample files that we've got with Dynamo. I'm also running in again the latest version of Dynamo, which is 2.0.1. And it's just going to take a second to open up because it's making Revit stuff. This is a Revit sample that goes and places structural framing elements. Again, this is just an example that's available out of the box in the help samples settings. This is a relatively simple workflow. It pulls a couple of curves out of this file. It extracts their geometry, and it places some points along the curves that come from that geometry, and then it uses those as a way to create structural framing. So again, that's just sort of this whole workflow is pulling some stuff out of Revit, placing some stuff sort of in the abstract along those things, and then creating some structural framing elements. This is just sort of standard fare for what it is that you can do with Dynamo. And again, just what it is that you get from the package manager traditionally these are all the tools that are available out of the box. And here are a number of libraries that I've downloaded from online from the package manager. So I've got my Lunchbox nodes, I've got some patterning tools, I've got some steel tools, that sort of thing. Also notice I have something that maybe most of you don't have in your menu, which says, I don't know if you can see that, probably not in the back of the room. And also it's underneath the GoToMeeting thing. If you look here, there, now you see it. This is Dynamoto. I've actually realized I've never said it out loud. Dynamoto is a package that I got. I went up and I looked around for Andreas Diekmann's stuff. I knew that he had this package and I downloaded it. Now I've got a new tool set that's showing up in my environment. So again, as opposed to what it is that you can usually do with the package manager of going and getting some nodes that you can then place in and do some new functionality, this is changing the environment of how Dynamo works. And it allows me to do certain things that are not available out of the box. So that one picture that I showed from John Pearson from 60-Second Revit that had alignment and organizational tools, he's made that using extensions. I don't think that he's put it out and shared it on Package Manager yet, but he could. This set of tools that is available for anybody to download, I'll just walk through a couple of the things that it does. So I now have my menu, added a dropdown, and it has a number of tools, all that have like a little bit of definition about what it is that they do. So again, sorry for the folks in the back. I'll read out some of these things. The titles of these things are find and fix ungroups, which basically says it can identify nodes that are not grouped and clean up your model for you. So what would that do? Let's say that I was going in here and I was saying, this is a group of things that are important to me. And I say, this is my Revit creating stuff. Fine. And maybe I go on to other parts of my model, do the rest of my thing. This does some interesting things where I can go in and I can say, find and fix ungrouped. If I open this up, it says, fix groupings. If I hover over, it says, click here to add nodes and nodes to the groups they intersect with. So if you just keep an eye on this stuff over here, you'll see that I've got levels and structural framing types that I missed when I was grouping these things. So if I say fix groupings, you see it just sort of took that overlap node and it included it in it. These are things that are like, we could have made tools, theoretically, that are available to do things out of the box. This is somebody who is managing lots of people's files and looking at keeping them all clean, and he's scratching an itch of, this is something that is important to his workflow. So he made a tool, and he thought that maybe other people would find it useful too. It has a number of other things that it can do that are in that sort of realm of work. So this is one that might get people's attention too, is this search in workspace. Search in workspace basically allows you to peruse an existing file and find specific nodes that you're looking for. Now, with this one, you know, this is sort of a trivially small one. I've seen graphs that have 200, 300 nodes sometimes, which I'm not sure is a good idea, but they're certainly out there. These massive files that have lots and lots and lots of different little pieces in them, and people need to sort of navigate and find all the different pieces of them. So perhaps I've got one of those graphs and I want to say, I want to find all of the things that either bring information out of Revit or write information back into Revit. Because many of the other nodes in one of these big graphs have nothing to do with Revit. They're entirely about logic and processing and geometry. And there's just a couple things that might specifically have something to do with Revit. So if I search for Revit, I get all of these things which have something to do with Revit, as opposed to things that are just generic operations of geometry or math or what have you. So I can say, well, now this is finding everything that has Revit in it. So it's looking in the node nicknames, the original names, categories, descriptions, all the rest, and it's finding all of these things. Maybe I only want something that has is in the Revit category. And I can select this down, and it gives me a smaller list. And I say, okay, well, there's a couple of element geometry nodes. These are the nodes that take elements that are coming in from Revit and basically extracts whatever their geometric representations are. If I'm looking for those sorts of things, I can click on them, and it'll zoom in on those pieces. And it'll zoom around to different things. Maybe I want to find the things that are creating or referencing level geometry, and I can click through to that. So basically, this is just another way to explore what's going on in your graph when you get into a certain level of complexity, or if you're getting a graph from somebody else. And anyway, this is just one more example of the things that you can do with this kind of functionality. There's a bunch of other tools in here. It's worth taking a look at, ways to isolate things that are happening in the graph, a way to sort of get templates, that sort of thing. There are other tools that are out there that people have started developing. There's, and I want to make sure I remember who did this one. Oh yeah, Design Tech is another group that's looking at some of this stuff. And I just want to show you this one. I don't have this one downloaded or installed, but this is just another one that's often asked for, but we have not gotten to the point of supplying it yet. This is a favorites. So if I am always using point by coordinates and a number node and a slider node and all these other things, I can add these things to this list so they can then have an additional palette, which just gives me my often used nodes and I can place them in. One of the questions that comes up when we show this kind of functionality, and frankly it's come up as soon as we opened up the package manager, is the question comes out of, well, why don't you just make these things that are being available in the package manager available out of the box? And a lot of it comes back to a couple different tensions in what we're doing with Dynamo. Dynamo is supposed to be a comprehensible and capable visual programming language. And I say those words for what it does as opposed to saying powerful and comprehensive, because those are different things. Visual Studio or other sort of full programming environments that are for, designed for computer scientists and computer programming, those are comprehensive and those are super powerful tools, and they are difficult to enter, and they take a certain mindset to get into them. One of the things that we've been trying to do is to curate the set of functionalities that are available in Dynamo to sort of meet people where they are, coming into things that can sometimes be a new world for them and a new kind of way of working. So as we add functionality to this environment, we also add complexity, and we also add an increased hill to climb in order to understand just what's even available. So we've tried to focus the development efforts on things that we believe are generalized to as many people as possible that are going to be using the tools, and open up that customization aspect for people to fill in the things that are important to their particular workflow. So all of that is to say that, yes, we could, back at the office, develop any one of these tools to sort of put into it. It's a matter of prioritizing what things we think are important to add into it, and also controlling how much complexity everybody needs to experience with the tool set. The other part of this that I would mention is that we've already done this with the regular nodes that come from the package manager, and this is probably where we're going to go with extensions as well. We've been keeping an eye on what nodes people use and what people find to be quite popular, and we have engaged in conversations with people who made those things to talk about bringing them into the main application when they appear to be very, very popular, very, very necessary. Again, with Andreas Dietmann's work with the clockwork nodes, one of the things that we did at one point was we found that he has hundreds of nodes that he produces in the clockwork package. Many of them are things that people absolutely find essential to what they're doing. And we talked with him about what things those were, and we talked to our users about what some of that functionality was. And a lot of that stuff we've ended up surfacing back into the main application, at which point he then takes those same functionalities out of his package, because now everybody has them. So he doesn't have to maintain them anymore, and we'll take care of maintaining them because it's demonstrated through his work that there is a need for this particular functionality. So there's this sort of ongoing dialogue with the community making tools and us trying to respond to what the community makes in order to sort of make something that is sensible for everybody. We did another project like that a ways back when there was a lot more Revit functionality that got exposed around annotation and documentation tools that we had not exposed out of the box. And so we actually worked with that developer to make some of the tools that he put together, and we pushed them back into the main application. We actually wrote the code, and we reviewed the code, and then we put it back in with tests and all the rest of the things to make sure that they're stable. Yes?
Can I ask a question about
Absolutely. By the way, people can throw things, raise their hands, all the rest.
Can you talk about packages and like Project Fractal and how those type of scripts can or cannot get into other third-party programs like Fractal?
Yes.
And the future of like packages and extensions and what that means for that as well?
Yeah. So this is, I was going to give people a choice about this at the end. That yes, we can get into that in the second half of that whole hog. But we're going to do it choose your own adventure sort of at this point here.
Okay.
But yes. And if we don't talk about it here, we can talk about it after. Okay. So anyway, the extensions is just sort of an example of the expandability of this tool set and how we want to sort of make this tool something that people can make their own. That also goes for internal development. One of the things that has been happening at Autodesk is we have started using Dynamo as a basis for development of our own internal tools. And we are not only going out and talking to folks like yourselves who are sort of in architecture and engineering firms and creating the actual buildings with the stuff, but we're also going around in Autodesk and we're talking with developers who are making more software and more applications. Autodesk is a big company. I think we're something like 7,000 or 8,000 people right now. So there are lots of different communities within the company itself. So there's sort of a campaign for the hearts and minds also within our own company about how we can use Dynamo basically as a platform for further development and as a sort of a transitional way for people to think about making tools that are for designers and engineers and making tools that are for something in between designers and engineers and people who are computer programmers, because we're seeing this emerging group of people who are very savvy in terms of both development of their own scripts and workflows, and also quite embedded in architectural offices and architectural workflows. So and all of that is to say is that these two people here are actually developers at Autodesk. Kean Wamsley is a longtime AutoCAD and computational design advocate for the company, but he is also getting into using Dynamo as a development platform as well. And Keith Alfaro is one of our relatively recent additions to the Dynamo group, who has been involved in hackathons and other sort of outreach programs with people who are developing code. This is where I'd like to sort of take the temperature of the room and see what other sorts of things might be interested to talk about. I think that is right at the halfway point. So I got a bunch of stuff we could talk about. And the two things that I was thinking that might be interesting for this crowd are, and both of these things and a few of these other things are about how we are using Dynamo as a basis for doing further development of things that you might not recognize as either visual programming or end user coding in some ways. One of them is basically there's been a lot of discussion in design computation world these days around, and actually just sort of in the professional mainstream about file interop and data interop. I am a person who is working in TechLab, and I want to get certain information to somebody who is working in Revit, or I am working in Rhino Grasshopper, and I need to also communicate with somebody who is working in Advanced Steel. Most of the ways that those sorts of workflows have been happening is people take a whole file that is part of their favorite toolkit of how their office works, and they either export some dumb version, or they send that whole file, or they have some method of exchanging with their collaborators that is verbose or requires some amount of dumbing down of their data, or somebody buying software that they don't use except for opening up and translating out somebody else's format. We've been doing a bunch of work around how to make that kind of workflow easier, and to make it something where you're only exchanging the kinds of data with your collaborators that you need to. So that's one whole sort of thread. And there's a Dynamo aspect of how you isolate and define the kinds of information that are important for you to share with other people. That's one thing. The other thing is, what Bill was getting at was, we have also been using these sorts of logical definitions that people make with Dynamo as the basis for doing what we would call design exploration. Some people call it generative design, some people call it optimization or optioneering. It's basically using these sorts of definitions to explore a larger set of implications. I can, on a very simple level, say, I'm going to define a cube as something that has 3 parameters into it, a width, a length, and a height. Given that kind of definition, there's a whole bunch of cubes or rectangular boxes that could come out of those 3 things. And how do I explore all the possible variations of that space? Or how do I find the variations of that space that fit a particular need? So on one hand, we can talk a little bit about data and data interoperability, or we can talk about optimization and option generation. So let's just do it this way. Data and interoperability. And option generation. Okay, well, everybody's shy here. Okay. Everybody gets 1 vote. Use it. Data and data interoperability. And options and optioneering. All right. Go with you, Bill. So, let me switch over to that. We got a half an hour. All right. I'm going to probably probably skip around in this one a little bit just to sort of get to the meat of the action. Hi, I'm Zach Kron. I'm the Senior Product Engineer. Okay, we'll do it this way. So I'm going to gun through a whole bunch of stuff at the front and then slow down a little bit towards where it gets to some other stuff. We have been talking a lot about how a lot of the time information in architectural projects is something that gets tied up in individual people's heads. And oftentimes it is not just in his head or his head. It has traditionally been his head in architectural and engineering firms. And it's also been tied up in these sorts of workflows that are highly manual or expressions of a highly manual drawing practice translated into screen. Here you've got somebody who is manually drawing straight lines and connecting them in order to figure out an idea. Here you've got somebody who is doing a version of that same idea of manually drawing things out. It's just that now it's happening on the screen and it's easier to erase. So what we've been looking at is how do we start getting more of the thinking and more of the processing and more of the drudgery work and more of the exploration work enhanced by what's happening in the computer. One of the examples that we talk about a lot in that is this is a NASA antenna. What does a NASA antenna have to do with any of this? This was something that was designed by humans. They said this was the sort of maximum way that we can conceive of as human beings looking at an antenna to make sure that it has maximum broadcast and receptivity for what it's supposed to be doing. Then they said, well, why don't we actually throw some computing power at this and look at different ways that we could simulate how this antenna broadcasts and receives information in the most efficient way. And some very smart people sat down and did some option generation on this kind of thing that just started throwing random numbers at this configuration until they found something that was optimum, something that started to show as much receptivity in the simulations as anything else. And this is what it was. And this is not anything that I would say would be designed by somebody sitting down and saying, I'm going to figure out the most logical way to do it. This is a brute force in some ways, way of looking at a problem and saying, I want to find the best way for me to optimize for receptivity in this particular goal-driven exercise. And it's going to come up with something that I might not have come up with, but it sure is going to work. This is something where you need to have some NASA scientists to do it. You also, historically, have needed to have a lot of supercomputers. You needed to have a lot of computing power. A lot of computing power has traditionally been something that is not available to run-of-the-mill folks. These are the kinds of computing power that have been available to larger organizations, things like space exploration groups, governmental agencies, large academic institutions. Now we're in a state where if you've got a credit card, you can access a whole building's worth of computers with Amazon data centers or Microsoft data centers or anybody else who is selling cloud computing. The availability of processing power is like beyond anything that anybody's actually been able to achieve before. So the ability to start crunching these sorts of numbers are things that people can start accessing. I'm going to skip that one. And I don't know how many people have seen, we've shown some of these presentations before, so I'm going to go through this stuff a little bit quickly. We've used some of these methods ourselves at Autodesk to start exploring design space and exploring what it is that you can do with this kind of computational thinking. We did an office up in Toronto called the Mars Project. But what we were doing was basically we said, we're going to do a layout of our own office based on a bunch of goals. That antenna that we were looking at before had goals. It needed to have a certain amount of receptivity. It needed to have a certain amount of broadcast ability. And those were all quantifiable things. You could say, I can run a simulation and I can tell whether I'm getting better or worse. In order to do this same process on our interior design project, we needed to quantify these goals. We needed to say, what are our goals, and then how do we measure them? So the goals that we decided that we wanted to emphasize were we wanted to have a highly productive office, we wanted to have a highly collaborative office, and we wanted to have buzz. There was a lot of discussion about what buzz meant. Buzz is about how do we make sure that people feel excited about what they're doing? How do we know that people are engaged with other people about what they're doing? And there were certain ways of actually measuring these things. Productivity can be measured by certain kinds of output. Collaboration can be measured by the certain amount of time that people have the opportunity to run into each other, the number of spaces that are available for people to meet and talk with each other. And after we sort of went through a larger exercise of defining quantifiable ways for us to measure these goals, we were able to start generating options that looked at these sorts of outcomes. I'm going to just sort of jump through a couple of these things, like we had different ways of visualizing it, have different ways of discussing with stakeholders about it. But in the end, what it was a bunch of math and a bunch of smart people writing a bunch of Python. I have no problem with Python, but it's not real accessible to a lot of people. Python is a programming language. It is a traditional coding environment where you can do just about anything with it. People who are very comprehensive with it can make extensions and applications that can run in your traditional design software. But it does require a fairly high degree of familiarity with topics around computation in order to write these sorts of things. It's very effective, and we can do all sorts of things where we can start generating lots and lots of options given some metrics about what we want to operate on and start visualizing them, making pretty pictures about them, and eventually starting to come up with real physical environments that we can build. And this is what we did with this project in Toronto. We used all of these methods to go in there and actually find, here's a group that is particularly going to be valuing daylight. And we're going to have a group that's going to be particularly valuing high amounts of buzz or interaction. And we're going to find the right places for them to occupy with the building, the right structures to facilitate that. And part of that has been this process of using computation power to explore lots and lots and lots of options and finding out which one of those options is better than another. One of the issues that comes up with optimization workflows is that you have contradictory needs. One way to think about that is when you have, I always like donuts. Donuts are really a great example for all sorts of things. Not only are they tasty, but there are also interesting geometric relationships. What donuts do, the reason that they are tasty, is that they are optimizing for surface area. If you had a munchkin does not have nearly the surface area relative to its volume as a donut. If you were going to put some geometry through some kind of optimization process, and you said, I want to get a lot of sugar on the outside of my baked good, you would come up with a cruller. That would be the optimization of, I want to get a lot of sugar on the outside of my thing. But if you say, I want to get a lot of sugar on the outside of my stuff, and I want to get as much chewy middle as I can, those two things are actually going to fight each other. If you increase the volume of something, you get a decrease in the surface area for the most part, unless you do some very interesting things with geometry. This is one example of an optimization problem where you have competing influences. So what we've been doing with these option generation models is how do we visualize to people that you're asking for contradictory things? For instance, if you were doing an interior layout and you said, I want my occupants to be able to have as much collaborative opportunity as possible, and I want them to be able to concentrate and focus on what they're doing as much as possible. Those things will be in conflict with each other. You can optimize for one or the other and say, if I want people to have the ability to concentrate as much as possible, you give everybody like a closed office with no windows, and they just see what's in front of them. If you want people to have the ability to have as much collaboration as possible, you have these big open office environments where everybody has to walk by everybody else. So how do you find the balance between those things? And how do you find some local optimum or something that is a nice balance between those two things? This proves to be not an easy problem to solve. And it is what we are trying to do with both saying we want to be able to unlock that ability for people to sort of make their own definition of what the problems are that they have. So what I was saying before, we've got this example from up in Toronto that was driven by people writing a lot of custom code, which is not accessible to a lot of people. It also represents sort of a black box of how things were made. It's difficult for other people to come into that environment and tinker with it to make it their own. And the other way is it's hard for people to sort of see the outcome of it. So that was what we wanted to address with Project Fractal, question that asked earlier. How many people here have heard of Project Fractal or have used it? Oh, okay, it's about maybe 30% of the room. Project Fractal is a tool that is based on Dynamo. This is our theme. Other things that have been built on Dynamo. This is a graph made in Dynamo that creates a stadium. It's kind of a big, complicated graph. It's not as complicated as many, but basically it has inputs that say, given a depth and a width of the stadium and maybe a rectangular profile and a elliptical profile, I want to get the optimum number of seats, and I want to also get as close to the playground, to the soccer field as possible. So if I want to get as many seats as possible, and I want to get them as close to the field as possible, those two things are going to fight with each other. So how can I look at different possibilities of this? This project that we had, which is called Project Fractal, was allowing people to sort of define that problem within Dynamo and then send it to an online service that would then generate all the possible outcomes of that design space. So what you would do is you would get all of the possible kinds of variations of that definition of a stadium. It didn't do anything around saying, are they better, are they worse? It just said, show me all the possibilities. It also had a lot of limitations around what you could run. This project is still ongoing and you can still participate in it. We've identified a number of limitations with it, which is there's a limited number of tools that you can use from Dynamo to run in Dynamo. So you can say, I can use all the tools that are basically out of the box with Dynamo. So I can't use packages and I can't use Python scripts, but I can send these things up and I can explore that design space that is defined by it. Where we're going with this is how can we allow people to add custom code to those projects? So how can you use packages within this sort of workflow? And how can we also make it directed so that people can say, this one is better, this one is not as good, and now I want to start homing in on a version of this design space that is better, by some definition of better. So, and there's a couple of other examples. This is, which one is this? I think that this makes, yeah, this is floor plans, and we've got one that does parking garages. There's a bunch of different examples of this sort of thing, which we can talk about more if people want to talk afterwards. Anyway, there is this facility that we have had for exploring design space, but in a non-directional way. What we're working on right now is construction examples and all the rest. Parking garages, pottery. These are my pots. I like doing pottery on the side. You know, and this can also be applied to other problems like iPhone cases. So this brings us to the new thing that we are evolving from Project Fractal, which is called Refinery. What Refinery does is it takes this same idea. We're building on the idea that people are generating a definition of their project space using Dynamo. They're saying, I'm going to define a logical set of relationships and a logical set of procedures that will create my design outcome. And I will use the power of the computer to explore that design space. But I'm also going to layer onto it the ability of running packages, that is, all those individual goodies that people have been able to expand Dynamo to do. But I'm also going to give it targets. I'm going to give it sort of, I'm going to give it value judgments for what I think is better and what I think is worse. So let's see if I can jump through this a little bit. So this is, by residential tower that's got some definition of desired window to wall ratio, size of window bays, different aspects that are how this building is put together that can be measured about whether they are better or worse. As I go through and I exercise this graph, it will give me different window to wall ratios, and it will give me different visual expressions. So what we've added to this is the ability to define an interface where you say, given things like, I'll just pause this for a second. So you can see, probably not in the back, but these different parameters are basically the different things that are important for me to manipulate about this building. So I've got the window to wall ratio, I've got balcony extensions, I've got window bays, those sorts of things. If I identify all those things as possible things to manipulate, I can also do something like I can define the outputs of them that I want to measure. And I can say, of all the outputs from this system, I want these ones to be maximized, and I want these ones to be minimized. Now start exploring this space. And when you press go, what happens is that Refinery will start generating lots of different options. And then it will say, okay, this set of options that I just generated had a bunch of the things that you wanted to be maximized getting higher and higher and higher, and a bunch of the things that you had minimized getting lower and lower and lower. And I can start graphing these things out as balancing points between these things that may be oppositional. There's a number of other things to sort of put into the consideration of this. A lot of the times when we've started experimenting with people with these sorts of tools, one of the things that has become apparent is that many of the problems that people put into these things really have like one good outcome. That is that some of the things that are trying to be optimized for, they don't have any conflict. They, I want to get, what can I come up with as a quick example? I want to get the biggest window. I want to get the biggest window to wall ratio that I can, and as much daylight as possible. That would end up with a glass building. Like, there would be no conflict. It would hone in on 100% glass. But if you said, I want to get as big a set of windows as I can possibly have, and I want to make sure that my solar gain in the summer is as low as possible, then you're going to have things that are actually fighting each other. So you need to start saying, well, which one is more important? And what these sorts of graphs and visualizations end up doing is that they show you sort of an optimum front where they will start to come into balance with each other, where you will find if you really want to invest in solar gain being low, you can optimize for that. If you really want to invest in your windows being very bright, you can invest in that. This is, so anyway, so the two things that this is a evolution of from Fractal are, again, it's able to run with packages and with other libraries that aren't defined out of the box, which was just sort of a basic limitation people have in Fractal. And then the other is that it actually allows you to sort of do guided exploration. We're still getting ready to get into sort of a real beta on this, but if you are interested, you can get in touch. We can talk about involvement with these sorts of things. But this is active working software right now that we are refining. Question?
Yeah, so when you integrate Fractal, could you also integrate Insight 360 with this type of processes?
That's right. So
when you're talking about like the window to concrete ratio,
right.
If you run it through Insight, it will help you maybe define some of those parameters before you get into your more further schematic design. Is there a way that those two programs, since they are Autodesk, are going to be compatible in the future to run?
Yeah, so our intention is to ultimately allow all of these sorts of tools to be able to talk to each other.
Okay. Because currently they don't.
What's that?
Currently they don't.
Currently they don't. No. That's true. So one of the biggest trajectories right now for what Autodesk is doing is we've built our sort of our base and reputation on big monolithic pieces of software that do everything that they're supposed to do within themselves. And where we're going is essentially breaking up big monolithic applications into, well, what we call services. So where you have, you can think of Revit as essentially a bunch of well-integrated services. You've got one function for making stairs. And the function for making stairs talks pretty well for the one that's making floors. And the one that's making floors talks pretty well for the one that makes walls. And all those things sort of talk to each other pretty well. But what Dynamo does is it takes care of the ones that don't talk well to each other. So if you've got all these different pieces inside of a Revit model that aren't necessarily integrated to the level that you want, Dynamo comes in and says, well, now I can start moving information in between all these pieces. I can also move them in between things like Excel or other applications that you might have. The way that the whole company is going right now is to say, there is a model that says, rather than having all of the intellectual property tied up in siloed applications, we want to put all of those pieces in relationship to each other so that they can talk to each other. So when you say, wouldn't it be great if the inputs and outputs, I mean, this isn't exactly what you said, but I'll restate it.
Okay.
If you could take all the inputs and outputs from something like Insight and say, so people don't know, Insight 360 is an environmental analysis and energy analysis application that is sort of a standalone environment. You send it
You
GPXML.
send it to the cloud through either Revit or Format.
Right.
And with Revit, there's different applications that you can use. So lead, credits, and so forth. But yeah, you send it there, it analyzes it, and it kind of gives you suggestions.
Right. And the great thing about these sorts of applications in the past has been they have a focused thing that they do. And you can, as a user, you can go to it and you can walk through that specific application. When you get a little bit more into the customization, like anything outside of that sort of straightforward path that this is what the tool is designed for, it is difficult to get it to talk to other applications. So a lot of what we're doing right now is we are building out many of those tools that we've made as monolithic applications in the past and essentially turning them into engines where you can pass it in a bunch of parameters and you can get a bunch of information back from it and you can sew them together into larger workflows that are customized to what you want to do. The balance of that is how do you make it so that everybody doesn't have to make their own tools? So there's that. That is essentially the back and forth that we're engaged in as a company, is exposing these things as granular tools that you can put together in ways that are appropriate to you, but also make it so that you don't have to rethink the whole concept of putting together a workflow from soup to nuts. But to your original question, yes, that is what we would like to do, is to have this kind of engine, which is essentially what Refinery is it's got Dynamo, and then there's another engine. And what that engine does is you feed it a stream of numbers, and it has optimization routines that it doesn't actually really care where those numbers are coming from. Here in our implementation, they're coming from Dynamo. But as an optimization engine, it basically is a piece of technology that has a number of sort of well understood algorithms for finding global optimization for different inputs. And it's something that we can keep adding layers to in terms of the different kinds of ways that you can optimize for things. But essentially that can be put in relationship to other things that are spewing out other numbers, which is essentially all that Insight 360 is doing. It's like you're giving it one set of numerical inputs and it's giving you another set of numerical inputs. It's packaging it up in a particular way. And that packaging both enables different people to use it, but it also limits how you can use it. And what we're trying to do is we're trying to open up all those different engines for different things to talk to each other. We're coming up very much on the end. That's pretty much what I wanted to cover here with this. I'll just show this one just to end. This is one way that we've been talking about sort of the trajectory of where we're going with this sort of way of thinking. The traditional way of doing design, where you've got pencil and paper and you're recording design decisions that you've already made. Perfectly reasonable, but that's the starting point. And this idea of generative design, where you're describing what you want to have happen, and you're describing the limitations on how you can achieve those goals. Parametric modeling with Revit basically represents that part of traditional design, where you're recording decisions that you have already made. What we get into with things like visual programming is you're defining a procedure. You're saying, do this, then this, then this, then this. Then you will have a predictable outcome. What we're talking about with Fractal is, given, do this, do this, do this, this, try some different starting points and see what the outcome is. Try some other starting points and see what the outcome is. What we're talking about with Refinery is saying, let's get more goal-oriented about that. Let's explore that design space, but let's put some values on what the outcomes are so that we can actually make some narrow decisions rather than looking at the entire design space. The eventual goal of this stuff is to actually get into things that are more associated with, there's a lot of fanfare right now about machine learning. Machine learning is about, let's look at all the decisions that we've made in the past and understand some ways that it can help us predict what we might do in the future. Let's look at information that we already know and that we have encompassed in other ways of thinking and seeing if we can find ways to explore them more quickly and with outcomes that might surprise us. So what we've been talking about is right there. We're in a very exciting time right now, sort of technologically, in terms of the resources and the hardware that are available to anybody that allows us to sort of start looking at some pretty advanced ways of thinking about design space and ways of solving problems that are more about defining what you want to have happen rather than defining a preconceived notion of what it is that you think should happen. I'm pretty excited about the things that are happening and about the kinds of work that everybody else here is doing and how we could all sort of work together on some of these things. So that's that. I think we have a few minutes for questions. I'm going to be here afterwards if people want to stick around and talk. But any questions on this? Sudden silence.
Lines are blown.
Anything from San Francisco?
No, thank you.
All right.
All right,
Well,
thanks.
hope you enjoyed your lunch.
Thank you.
Sure.
Yeah.